let's talk about transforming functions, and we're going to focus on discovering how transformations affect intercepts. Remember that transformations just mean that we've changed the function somehow so that it's not the same as the parent function. So, for example, if I have a parent function of x squared, if I divide it by something, if I subtract something from it, if I multiply it by something, these are all going to cause transformations. So we're just going to say, we're going to look at the x-intercepts and the y-intercepts before the transformation and after the transformation, and see how what we've done affects the intercepts of the equation. Okay, one more time. We're going to look at a function before and after a transformation and figure out how the intercepts are affected by that transformation. So when we're talking about a function as a whole, I've done a couple on these, so you should already be somewhat familiar with this table. We know that horizontal translation happens when we do something to x, right? When I do something to x within the parentheses. Every time I do something to x and x alone, it causes horizontal movement. Okay, so again here, I've done something to x. I've multiplied x by something. It causes horizontal stretch and compression. On the right-hand side, you see if I leave f of x alone but then add something to it as a whole, I had vertical translation. If I leave f of x alone and then multiply something by it as a whole, I get vertical stretch and compression. Now this is something I've gone into more detail in previous videos, so if you need a recap, go back, watch one of my former transformation videos. That's not what we're going to focus on today. So if I have f of x, there are many ways I can transform it. Again, I can subtract something. Again, notice that this subtraction is happening to x only. I can add something to the, or subtract something to the function as a whole. I can multiply function as a whole, or I can do something again to x alone. These are all ways of transforming my function. Now, if I look at them in here, in this slide I have them broken down one by one, right? In this situation I represent all four happening at once. Remember that A, when we talk about A, always controls vertical stretch and compression and reflection across the x-axis. K always controls vertical translation, H always horizontal translation, and B horizontal stretch compression and reflection across the y-axis. Now you've seen these keys from me before. Again, hopefully if you've never seen me put a key like this on the screen before, go back, watch some of my older transformation videos. I'm not going to have us practice so much with this. In the past we've done a lot of identifying what type of transformation is happening, comparing it to a key, identifying what that means. We're not going to do that so much today. Again, our focus is on what happens to the intercepts when we do these transformations. So let's look at a couple pictures here. I know these are kind of busy photos, but let's look. So on the left-hand side, we have horizontal stretch or compression by a factor of b. Blue is f of x. It's our original function. The red is f of 2x. f of 2x. So notice what's happening. We're going to look at our x-intercept and our y-intercept. Remember, our x-intercept happens where the graph crosses x, and our y-intercept happens where the graph crosses y. So this is my y-intercept. It's where I'm hitting the y-axis. Notice that when I made a horizontal change, my y-intercept stayed the same. That makes sense, right? Because y controls up and down. So if I made a horizontal movement, if I have a graph like this, and I move it over, it's still just as tall as it was before, right? So if I have a 6'5" person and I tell them to walk 3 feet to the right, they're still 6'5". It didn't change how tall they were. But notice that the x-intercepts are different. And this makes sense, right? Because if I look at where the feet of the 6'5" person were before I had them walk 3 feet to the right, it makes sense that their feet aren't going to be in the same place, right? I have made them move. What about vertical change? So, vertical stretch or compression. Notice when I made a vertical change, the y-intercept changed. It's no longer the same. So think of a 6'5" person. If I look where their head is at, how tall they are, 6'5", I tell them to squat, their head's not going to be at that 6'5" mark anymore, right? So maybe they're down to about 4 feet. because I've told them to squat. However, that's just a vertical movement. Horizontally, if I'm looking at the placement of their feet on the ground, well, squatting didn't make them move their feet, right? Their feet are in the same place. So all my x-intercepts are in the same places. So again, horizontal movement only affects x-intercepts. This makes sense. This makes sense because x controls left and right. Vertical compression or stretch only affects y-intercepts, but not x. And we'll put that into practice. And then quickly with reflection, if you reflect across x, y stays the same, but x changes. If you reflect across, if you reflect across y, x are negated, y stays the same. If you reflect across x, x-intercepts stay the same, but y is negated. So this makes sense. If you think about this is the line that we're folding the paper on, it makes sense that if we reflect across x, x stays the same. If you reflect across y, y is going to stay the same. So we're going to prove this by just double checking and looking at our intercepts. So they've already told us very clearly right here that if you horizontally stretch or compress by a factor of b, that you just multiply your x-intercepts by b and your y-intercepts stay the same. They've told us that your vertical stretch or compression by a factor of a means that x stays the same but y will be multiplied by a. But who's going to remember that, right? So unless you have that key in front of you, which who knows if you will or won't, you need to just be able to remember how to double check how to find your x and y intercepts, and let's observe what happens to them. So for example, I've got this f of x, this is my original function, and g of x is my transformed function. So f of x is equal to 3x plus 6, g of x equals 5 times f of x. Notice that I've got 5, I'm multiplying it by f of x, so right away, hopefully, you'll think back to those tables we just looked at that told us what happened when we multiply f of x by a factor of something. What's going to happen to our intercepts? Well, the only way to know is to find it. So let's look at our x-intercepts. The question is, what is the x-intercept of g of x? So g of x equals 5 times f of x. So I've written f of x here. I simplify. G of x equals 15x plus 30. Again, I took f of x, multiplied the whole thing by 5. To find my x-intercept, I set y equal to 0. This is something that students often get backwards, so think about it for a second. If I told you to find x, you'd set y equal to 0. If I told you to find x, you'd set y equal to 0. So often, students will set x equal to 0. If I tell you to find x and you set x equal to 0, well, you've already decided what x is. You just told me it's 0. So it makes sense that if I want to find x, you must set y equal to 0. So I've set y equal to 0. So 0 equals, in this case, y could be the f of x or g of x, right? These are all the same. So 0 equals 15x plus 30, and I solve for x. I find that x equals negative 2. So my x-intercept is negative 2. So if my x-intercept is negative 2 in my transformed function, do you think it'll be the same in the original function? Let's find out really quickly. If you take a look, if you take 3x plus 6 and set it equal to 0, and you do some quick computing, we get negative 6 equals 3x. It looks like this x-intercept is also negative 2. So notice that by taking the function as a whole, multiplying it by 5, nothing happened to the x-intercept. In both cases, it was negative 2. That's because this 5 causes a vertical stretch. So horizontally, nothing changed. Let's look at another example. So given the function below, what is the y-intercept of g of x? What's the y-intercept of g of x? So f of x equals negative 5x, g of x equals f of x plus 20. So g of x equals f of x, this is f of x, and I've added 20 to it. So if I want to find the y-intercept, remember, if I want y, I set x equal to 0. If I were to set y equal to 0, I've already decided what y is. So I set x equal to 0, and then I solve. So negative 5 times 0 is just 0, so g of x equals 20. So my y-intercept is equal to 20. Is this different from my original function? So y-intercept for my transformed function equals funny. This is transformed, this is original. If I look at my original function and I wanted the y-intercept, I would set x equal to 0, and I would have negative 5 times 0 equals 0. So notice that when I added 20 onto the function, I also added 20 onto my intercept. This makes sense because adding 20 took that function, whereas originally it would have crossed through the origin. Now I've translated it upwards 20 units. So my y-intercept went from 0 to 20. Let's practice again. Again, we're finding the y-intercept of g of x. So I've got my original function and my transformed function. In my transformed function, I'm dividing the original one by half. So 1/2 f of x. So if f of x is 10x minus 2, I multiply that whole thing times 1/2. G of x then equals 5x minus 1. If I want the y-intercept, I set x equal to 0, and I find that my y-intercept is negative 1. My y-intercept is negative 1. Now I've already answered the problem, right? What is the y-intercept of g of x? Well, it's negative 1. But I still, for the sake of comparison, am going to say, well, is that different from the original function? So if the original function was 10x minus 2, and I want to know the y-intercept, I would set x equal to 0. 10 times 0 is 0. My y-intercept in the original function was negative 2. So notice that by multiplying 1/2 by the whole function, my y-intercept also was multiplied by 1/2. I went from negative 2, half of that is negative 1. So it's just interesting to observe the patterns. I think this is cool because in the future, if you got some really, really hairy function for g of x, it might be easier to just compute for f of x, and you would know, okay, well, since something horizontal happened, my y-intercept will be the same, or you might know that you need to multiply by a certain factor depending on what's happening with g of x. So I think it's cool to understand the relationship between the original function, the transformed function, and the way they move depending on what type of transformation they undergo. Let's do another one. Given the function below, what is the x-intercept of g of x? So I've got my f of x, I've got my g of x. G of x is 5 times f of x. So I'm going to take 5 times 2x plus 11, simplify. I want the x-intercept, so I set y equal to 0. So 0 equals 10x plus 55. Solve for x. So x equals negative 5.5. Very cool. So I've got my x-intercept. For my transformed function, my x-intercept is negative 5.5. Let's compare it to the original. For my original function, my x-intercept, I would have set y equal to 0. Solving for x, I would get negative 11 over 2, which is still negative 5.5. So again, notice that going from my original function to my transformed function, I multiplied the function by 5, but my x-intercept stayed the same because I didn't affect the equation horizontally. I only affected it vertically. So given the function below, what are the x and y-intercepts of g of x? So this time we need to find the x and y-intercepts. So I've got f of x. I know that g of x is equal to twice f of x, so I'll take f of x and multiply it by 2. Simplify. For my x-intercept, I set y equal to 0, solve for x. So x equals negative 1.5. So that's my x-intercept. For my y-intercept, I take x, set it equal to 0, so my y-intercept is equal to 12. Now, I've been verbalizing a lot what happens with our intercepts. Let's take it, graph sketch. Let's take a moment to graph these. So I had my original function, f of x equals negative 9x plus 6. G of x, I took that function and multiplied it by 2 to get negative 18x plus 12. So I've got my original function here in blue and my transformed function here in red. Notice that when I multiplied by 2, my x-intercept stayed the same. That's because multiplying by 2 was a vertical stretch, which means that horizontally my x-intercepts stay the same. So you can see that in both that I've got x equals negative 1.5, so my x-intercept, negative 9x plus 6. Looks like I have a tiny error here. Oh, yeah, so I accidentally dropped a negative sign here. So that should be negative 18, which means I end up with a positive 1.5. That's my mistake. So I have positive 1.5 for my x-intercept, and then notice the change in my y-intercept. It looks like it goes from 6 to 12, right? So in blue, it's at about 6. In the red one, it's at 12. So this makes sense. When I multiplied by 2, my original y-intercept of 6 was also multiplied by 2 to get my new y-intercept, which was 12. All right, so nearing the end with our practice here. X and y-intercepts of g of x. I'm going to do this one a little bit differently. Let's find the x and y-intercepts of f of x as well. So for f of x, my x-intercept would be when I set y equal to 0. So 0 equals 45x minus 30. 30 equals 45x. So x equals 30 over 45. 30x equals 30 over 45. If I divide both of those by 15, I get 2/3. So my x-intercept is 2/3. My y-intercept for my original function, I set x equal to 0, and I get y equals 0 minus 30, so my y-intercept is 30. Now can you predict, I've got my x and y-intercept, I'm multiplying by 1/3. Which of these intercepts will change? Which one will stay the same? So comparing x-intercepts, I take 1/3 of f of x to get g of x. So 1/3 45x minus 30. So 45 divided by 3 is 15. 30 divided by 3 is 10. So g of x equals 15x minus 10. Now to find my intercepts. My x-intercept, I'll set y equal to 0. So I get 0 equals 15x minus 10. So 15x equals 10. Divide by 15 on both sides. X equals 10 over 15. X equals, dividing by 5, is 2/3. So notice that my x-intercept in both cases is 2/3, which means that this 1/3 multiplying by 1/3 was a vertical change. So that means our y-intercept must be different. So if we multiplied our function by 1/3, what do you think if I started with 30, then my function was multiplied by 1/3, what do you think my new y-intercept will be? Do you think it'll be 10, or will it be something else? I said 10 because 10 is 1/3 of 30. Let's find out. So g of x equals 15x minus 10. If I want to find my y-intercept, I set x equal to 0. So y equals 0 minus 10. So sure enough, my y-intercept is equal to 10. So my y-intercept became 1/3 of the original intercept because I multiplied, I vertically compressed by a factor of 3. So that's it for this lesson. I know it was a little bit fast and furious with the examples, So I would recommend even going back to the beginning of this video. Maybe now those graphics that I showed you, as far as the graphs and what happens to the intercepts, will make a little bit more sense. Of course, you can always contact me if you have any questions.